or your white blood cells primarily function for immunity, infection, or inflammation. So generally speaking, your white blood cells play the role of policemen in your body. So they fight off foreign invaders and they fight off infections. So features of your white blood cells include that they have a nuclei and organelles, but they do not have, take note, they do not have hemoglobin. So this is why you see white blood cell, wala siya sa red na color. So we have the types of white blood cells which we discussed previously. You have two major categories, your granulocytes and your agranulocytes. So under your granulocytes, you have three different types of cells. You have your basophils, eosinophils, and neutrophils. So you can remember that with the mnemonic or acronym BEN, basophil, eosinophil, and neutrophil. So your basophils are typically for allergic reaction. Your eosinophils are there for parasitic infections, and they also combat allergic reactions. So react siya sa reaction ng basophils. Next, you have your neutrophils. So these react, or these are for bacterial infections. So its lifespan is 4 to 5 hours in the circulation kung kapatrol lang siya or galibot sa circulation. But when it is deployed to your tissues, your lifespan is 4 to 5 days before it dies. Okay? But in cases of extreme inflammation or infection, the lifespan of your white blood cells may be shorter. So parehas na wala sa tira na kung ang soldier ipadala mo na sa war, di ba, the shorter ila lifespan. So the same na siya sa inyong granulocytes. That's what happens to them since they are the line of defense of your body. Next, we have your agranulocytes. You have two types. You have your lymphocytes and your monocytes. So lymphocytes included that they are your T cells, your B cells, and your natural killer cells or NK cells. These typically negate immune responses. Sila ang main na nag-aatubang sa virus or sa bacteria. And their lifespan can be months or years. So this will be explained later on na akalawin sila yung months or years. Next, we have your monocytes. So your monocytes, in its entire lifespan in your body, it can become your macrophage. And your macrophage or macrophages perform phagocytosis. So this is the eating of your foreign invaders. So panipon ni macrophage ang foreign invaders by way of phagocytosis. And the lifespan of your macrophages are already months, or they take months before they die off. Let's talk about how they exit the bloodstream and go to the tissues. So we have three ways, or three processes that allow the white blood cells to go to the tissues. Number one is your diapedesis or immigration. So this is what happens generally. So this is your blood vessel and this is your infected tissues, or let's say this is the infected organ. So ang goal ni white blood cell, mahalin sa bloodstream kag ma-transfer sa organ or sa tissues, di ba? So how do they do that? They do that in three steps. Number one is rolling. So ma-roll si white blood cell going towards the edge of your blood vessel, and then it will stick. So matapik siya sa walls, ma-roll, ma-stick, and lastly is to squeeze out of the capillary. So ma-roll siya, ma-roll si white blood cell, ma-stick, matapik siya sa wall before it can squeeze through the tiny pores in your capillaries para makag-go na siya sa inyong tissues kag maka-respond accordingly. So this is how the apedesis or immigration happens. Rolling, sticking, and squeezing through. What else? So they can pass through by way of an amoeboid motion. Diba? Have you seen a picture of an amoeba? Diba? It's composed of squiggly lines and they move that way as well. So this would make it much easier for your white blood cells to squeeze through kung amoeboid motion siya. Because this would mean that this is very pliable. And lastly, we have the process of chemotaxis. So ano na siya meaning? This just means that when, for example, si white blood cell na nakago na siya sa infected tissues, it can release certain chemicals na kumbaga ginasignal niya ang other white blood cells or immune cells to respond to the situation para makatultol na sila. Kumbaga, this is like a homing device or signal para kabalo ang iba ng cells na yung makatultol. Okay? And after they fight off the infection, they can die there and pile up. So ang graveyard of white blood cells in an infected tissue is called pus. Iyan po siya ang pus or nauna. So those are the dead white cells that have already consumed or nakado na sila sa function nila sa infected tissues.
Our body has a powerful army that protects it from various types of threats. These threats can come in the form of mechanical injuries, the entry of germs, or the entry of other foreign particles like dust. This personal army is called the immune system. Every day we encounter a huge number of bacteria, viruses, and other disease-causing organisms. However, we don't fall ill every other day, which is due to our immune system, an army of cells that is always roaming our body, ready to ward off any attack. The immune system can be broadly divided into two parts, innate and adaptive immunity. Innate immunity, or non-specific immunity, is the body's first natural defense to any intruder. This system doesn't care what it's killing. Its primary goal is to prevent any intruder from entering the body, and if it does enter, then the immune system neutralizes this intruder. It doesn't differentiate between one pathogen and another. The first component of this defensive system is our skin. Any organism trying to get into the body is stopped by the skin, our largest organ, which covers us. Secondly, there is the mucous lining of all our organs. The sticky, viscous fluid traps any pathogens trying to get past it. These are the two physical barriers. However, we also have chemical barriers, such as the lysozyme in the eyes or the acid in the stomach, which can kill pathogens trying to gain entry. The genitourinary tract and other places have their own normal flora or microbial community. These compete with pathogens for space and food, and therefore also act as a barrier. The next line of defense is inflammation, which is done by mast cells. These cells are constantly searching for suspicious objects in the body. When they find something, they release a signal in the form of histamine molecules. These alert the body, and blood is rushed to the problem area. This causes inflammation and also brings leukocytes, or white blood cells, which are soldiers in our body's cellular army. Once they come, all hell breaks loose. Sometimes, however, the intruder may not be a germ, but rather a harmless thing like a dust particle. The body still causes a full immune reaction to this intruder, which is how allergic reactions occur. In the fortress of our body, the leukocytes are VIPs. They have an all-access pass to the body, except, of course, to the brain and spinal cord. Our leukocytes come in many types. Those that belong to the innate system are the phagocytes. These cells can either patrol your body, like the neutrophils, or they can stay in certain places and wait for their cue. Neutrophils are the most abundant cells. They patrol the body and can therefore get to a breach site very quickly. These cellular soldiers kill the infectious cell and then die, which leads to the formation of pus. There are also the big bad wolves, or the macrophages. These cells are like hungry, ravenous monsters who simply engulf unwanted pathogens. Instead of roaming freely in our blood, they are collected in certain places. These cells can consume about 100 pathogens before they die, but they can also detect our own cells that have gone rogue, such as cancer cells, and kill them too. Beyond that, we also have the natural killer cells. These cells can efficiently detect when our own cells have gone rogue, or are infected with, say, a virus. NKCs detect a protein produced by normal cells called the major histocompatibility complex, or MHC. Basically, whenever a cell isn't normal, it stops producing this protein. The NKCs move around constantly, checking our cells for this type of deficiency. And when they find an abnormal cell, they simply bind to it, release chemicals, and destroy it. The last cells of our innate immune system are the dendritic cells. These are found in places that come in contact with the outside environment, such as the nose and lungs. They are the link between our innate and adaptive immune systems. They eat a pathogen and then carry information about it to our adaptive immune system cells. This information is produced and shared in the form of antigens. Antigens are the traces that pathogens leave behind. They are molecules found on the surface of pathogens that can be detected by our adaptive immune system for recognition. The dendritic cells pass on this information to our T cells. However, macrophages can also perform this function. Now, there is also the adaptive or acquired immune system. This system is more efficient as it can differentiate between different types of pathogens. It has two main components, T lymphocytes and B lymphocytes. T cells come into play when an infection has already occurred, thus bringing about the cell-mediated immune response. B cells join the fight when the pathogens have entered, but haven't yet caused any disease. This is called the humoral immune response. Some T cells take signals from the dendritic cells or macrophages, and are thus called helper T cells. They perform two key tasks, forming effector T cells, which are basically cells that cycle through the body and call in the cavalry, namely other white blood cells. Helper T cells also form memory T cells, which keep a record of this antigen for future reference. Sometimes, some cells of our body know that they have lost the battle. They have become heavily infected with pathogens, so there is no hope left for them. At this point, the immune system brings out the cytotoxic T cells. These cells rush over and perform a mercy killing for the infected and dying cell. Furthermore, we have the B cells. They produce chemicals called antibodies, which fit on the antigens of pathogens, much like how a lock and key fit together. These antibodies crowd around a pathogen and act like tags. They signal the macrophages to come and kill the marked pathogen. B cells also produce memory B cells when they encounter an antigen. The B and T memory cells jointly maintain a record of all encountered infections, and thus strengthen and solidify the body's immune response to these infections in the future. Our innate response is quicker, though non-specific. It gets into action within hours and is pretty strong. However, when things get out of hand, the innate system calls for help from the acquired immune system. This system can take days to mount a response, but the next time we encounter that pathogen, it won't make us get sick.